Good evening, friends. Welcome to ESN Academy. And we are into embedded system programming, week 12 and day 2. And we are discussing about microprocessor buses. And we discussed about UART. Now we are discussing about SPI and I2C. We have first discussed I2C. Today, let us try to complete the I2C and SPI. So by that way, you can able to use them on your day-to-day life, other projects also. And we will try to go in depth from next week onwards. So they are all, we discussed about two type of buses, parallel and serial bus. And SPI is a serial bus. Sorry, I2C is a serial bus. So let us get into the board and continue our discussion. Okay, so let us we had two outputs from the master and slave. Slave has two inputs. We call SDA and SCL or SCK. Now, this is bidirectional. That means that master can send and slave can send. As usual, there is the master has a control over the switch and master have a latch. Sorry, slave. See this idea. Whenever you wanted to transmit and receive, this is what happens. Now, latch input, latch input. And I have a switch. So if I control the switch, I transmit. If I use the latch, I receive it. That's the thing. So if I control the switch, I do the thing. So it's my wish. Now the wish is, we have discussed, whenever I transmit something, I do start, data, and stop. The start is nothing but whenever there is a clock is high, if the data changes, normally as a rule in SPI, in I2C, there's sometimes confusion, man. These two are we repeatedly using that. In I2C, when the data is there, clock will pulse and that's it happen. So when there is a change in the clock, data will be stable. So data will not change when the clock is high, but except only one time, start and stop. So they have a small circuit to detect that. Okay. Now when let us assume that right now, master is sending something to slave. Master will send start, then it will send about 8 bits. Out of 8 bits, 7 bits are address. And 1 bit is read or write bar. That's it. Now, after our man receives 8 bits here, a slave, the slave sends a acknowledgement. The acknowledgement is not 8 byte. Acknowledgement is only 1 bit. What happens? He pushes, let's say it's ground. He pushes the switch down, telling you that I got 8 bits. But what that guy will do, let's say he got 8 bits, 10110011. This is for read, and this is for his device address. He will compare, his name is also 1011001. If this matches, okay, if it matches, then that guy will go and press the switch, telling him that I got, so after 8 bits, this guy will stop the switch. Who? Our master. I told you already, there is a pull-up here. There's a pull-up. 5 volt. Now, when master is not pushing the switch, is grounded. Is ground. When master is not pushing the switch, or slave is not pushing the switch. Okay. What is happening? When both of them are not pushing the switch, this line is open. That time it is pulled up to 5 volt. So by default, the line is 5 volt. Now, I push the data, I transmit. This we are very clear. If you say that every byte, see, there's a understand one thing, I send the start and stop. Start is when there is a clock is high, data changes from high to low. When there is a clock is high, data changes from low to high. In between, I transmit data. How much it's your wish. Now, what I do here is, I transmit 8 bits. Who master? After sending 8 bits, I wait for acknowledgement. Who gives acknowledgement? This guy. By which? By pushing the switch down. So, but you see and understand, on this 9th clock, master off. Master switch is off. Now, slave on. The first byte tells you the device address. Once it is latched, for example, you have multiple devices. You have multiple devices. The same thing is going. Now, when you have multiple devices, device 1, device 2, device 3. Each one is having address, 7-bit address. This is for read write. Now, that device, once it latched, once it acknowledged for the first device address, then whatever you transmit till the stop, only that guy will accept. Till the stop, other people will not accept. They say that hey, some 2 people are talking. I should not get into them and disturb. That's the way they do that. Am I right? Is this clear or not? Is this clear or not? That means that I can transmit I can select device. You can use multiple methods. You can use multiple method. Method one is I have a microcontroller. I have a port. Let's say port C, bit 0 and 1. I can do that. I can do the whole thing by software. You can transmit the whole data by software. That means that you are simulating I2C on software. Second one, the second method is you have 2 microcontrollers. One microcontroller, you will write the software, I2C software, but the data will be given by the other microcontroller. You will transmit. Both of them are your software. While ACK, will the STA in master be low? No, this is a common wire. This is a common wire, please. See, this wire is a common wire for both SDA. Both of them are connected ground. Both of them have a switch. Okay. This is for transmitting. Now, both of them are having I told you, a latch. Both of them are having a latch for receiving input. Suppose when this guy gives a acknowledgement, Okay. That means that he pressed the switch. After you transmit 8 switches, then you transmit the data, acknowledgement. He pushed the switch. Now this becomes 0. Okay. Now you have a clock. SCK will pulse. When the line is low, for acknowledgement, you will pulse the STK. When you pulse the STK, this STA will be latched here for the master also. So the ACK received sent by the slave will be received by master. Same way, when a slave sends the data, when master pushes, he gets the ACK. So this ACK is nothing to do with the master or slave. Whoever transmit after 8-bit has to wait for the acknowledgement. That's the rule. Is it clear? While ACK will be STA in master. Correct. Perfect. That's why I only say direction. The SCL or SCK, serial clock, controlled by the master, not by slaves. Please understand. It is controlled by the masters, not by slave. Okay. Is it clear? Now, the second method is you can have a 2 microcontroller. You can write a software here to be a I2C controller. This is your main controller. You send the parallel bit, you send the data. The third one is you have a microcontroller. It's having a built-in I2C controller. Who decide this? That microcontroller manufacturer itself decide. So you can just tell him the data, he will transmit. You need not to do anything. Okay, that you should start understanding here what is his registered values and what is that. So a multiple way you can do that. Now I'll tell you the important trick of the I2C controller. That's the trick. I2C is used only for sending a data, only selecting and sending. If you come back to our normal, this one, that is in our microprocessor. In the microprocessor, you have a data bus, address bus. The address bus, you have so many 16 lines. We use few lines to select the memory and few lines to select the chip select. This is what in this case, there we call chip select. Here we call device select. Okay, both are same. Okay, but here they fixed. There it is not fixed. You go and see the memory map once again. There it is not fixed. Depends. If you have a 32K, you will have 15 wires and 1 wire. If you have a 8K, then 13 wires and 3 wires. But in the case of I2C, this is always 7 bits. Okay. Now, the trick is, we have 2 things. One is memory or controllers. That's what we discuss. In our microprocessor, we have either memory, ROM, or RAM. In the case of ROM, I only read. In the case of RAM, I write and read. That is possible. But in the case of controller, I write some data. He will do some activity and you will read the status. For that, he has some registers. Unfortunately, in the case, you don't know what that guy say, unless otherwise you read the data sheet or user manual of both, if you don't read them. Now, the trick here is, here also same thing. Here also, the trick is that if I have I2C base, forget about this. I have I2C. And I have so many devices. I may be having a RAM I2C base or I may be having a ROM I2C base. I may be having a some controller. In the case of RAM, what will I do here is, let us say this guy's address is 12. This guy address is 13. This guy address is 14. All of them are connected through I2C. Okay, all of them are connected to I2C. Clock and data connected. Now, the trick here is this. I transmit start and I put 12 and write as a 1. Am I right? A 1 for read, or let's say 0 for write. And 12 is for device select. 7 bits. So when I put the start, everybody woke up. This guy woke up. This guy woke up. This guy woke up. Then I put 12. This guy compares. No, it's not mine. It is not mine. This is mine. Yes. Now you put 0. You want to write. So this guy understand. You're going to write. Now what you do here is you transmit. Then what happened? This guy gives you the acknowledgement. Understand? Acknowledgement. Let me put the acknowledgement in a different color. You will know that. This acknowledgement. It's nothing but acknowledgement, nothing. He pressed the switch. Then it became low. Instead of master keeping the low, now slave will make the things low. I got acknowledgement. Now, our man, let's say this RAM is 256 bytes. How many bytes? 256 bytes. Our next 8 bits will be address. Then slave will send acknowledgement. Then I will send data, 8 bit. Then slave will send acknowledgement. Understood. Then I will send the stop. So I start, I stop. What all I am doing? See, what all I am doing? I am doing the device select. I am doing a device select. If you understand this, start. Okay. Now we start. We know that what is meant by start. We know that I make the data high when the clock is data high to low when the clock is high. So that means start. Now then I transmit 8 bits, device address and the read write bar. How do I transmit data? If it is 0 means I make it 0, then the clock will be pulse. Every time you send the data, the clock should be pulse. If a clock is not pulsing, the other guy will not accept. Now it's done. After that, this guy slave, this is one master. This is master. This is master, 8 bit, device address and read write. Then this one called acknowledgement by slave. Then master sent 8 bit address. That because this guy's RAM is having 256 bytes. 256 bytes means 00 to FF. That is given. Let us say I'm sending address 40. I send the device address is 12. I make write as 0 because read or write bar. Write bar means 0. Now our master slave sends acknowledgement once again. 1 bit. Then understand our man sent master sends data as 21. Then slave sends acknowledgement. Then master sends a stop. That means that what you have done at location 40, you have written data 21. At here, at the RAM, at location 40, you have written 21. Now you see here 1 pulse, here 8 plus 1, 9, 10, 18, 19, 27, 28, 29. You have used 29 clocks. Understood? You use how many clocks? 29 clocks. But whereas if it is a microprocessor, I will send the address, I will send the data, I'll make write. It will be written here at 40. One write, enough. Understood? That's why this is faster parallel. And serial advantage is I'm not going to do every time. I'm going to write it and keep it. It will be there for a long time. I'm not going to access now and then. Maybe every 1 hour once or every 1 minute once I'll access. That's fine, man. That time, why should I use unnecessarily so many wires? So when you don't use them very frequently, let us say that this guy, this controller is called temperature controller. He measures the temperature and keep the value here on a register. You want to read, you will say the address is 14. Address is 14. Then you will say read as a 1 because you're going to read. Now, let us assume that this guy might be having only one register. For example, only how many register? Only one register. Since you are reading, automatically next to one, when you give a read, you will get the data, that is your temperature. Then master will send acknowledgement. In this case, master, because understand the data is given by slave because you ask read. Since you ask read, the data is given by the slave, then you put acknowledgement. Then you put acknowledgement, then you make stop. Understood? Now the temperature comes to you. You read the temperature by making it small. That is what I'm telling now. What I'm trying to say is that this controller will tell you what is what. You don't know. What register is what, every information. What is a spy packets. Why I am telling this? Why I am telling this is very, very important. This is what the thing you need to understand when you, as a software person, after embedded software person, you should understand this thoroughly. That means that I have a microcontroller that is having a microprocessor that is having an I2C controller. Now I have function called I2C write, I2C read. Using this, I can write 8 bits and I can read. Okay, that you should know when to write, when to read. Now, after this, now let us assume now how I'm doing now. I have 4 devices which are connected on the I2C. 4 devices. This is 10, 11, 12, 13. Okay. Now I want to write something to this guy. 12. I'll say I2C write. I2C. First I'll say I2C start. The function. This function will make start the I2C. That is when clock is high, data is low. This will be done by this guy. Now I2C is started. Then I'll say I2C write. What do you want? You want to write 12. 12. But that is not submit. That is only device address. You have to make 1 bit as a read or write. Am I right? Then you are with, depends. Let us say that my read or write is I'm going to write. Then R with write. Which you will say that hash define. Right. So since you have done a hash define right, you know when you write it. Now you have to do only this. This I2C write will give it to the I2C controller. The data. Okay, for example, you are writing. That means that device address is 12.0.0.0.1100. Then I write is 1. So it become this 0x8c. That will go here. And that guy will transmit the data. Your job is done. Once it is done, you will come out. The data is, then you will say, now you are given only device selected. Am I right? Then you will do that I2C write address. I2C write data. Okay, or that I2C write 40, I2C write 21. You will write this function. Then finally you will say I2C stop. Am I right? Now the trick is that if this is called RTC, real-time controller, which gives you the time and date, everything, and this is temperature controller, each and every one is having a huge functionality. They have lots and lots of data to be written. You will start doing that. You will read the data sheet and do that. We will use at least one of the controllers. We will write it. Okay, let me finish this and spy. Then I will show you that how to write in one controller. But the top level you should understand. See, all the things are fine. But when you don't understand in top level, nothing will be useful. The top level, you should write the function. If you can able to write the functions, these 5 functions by yourself on your controller using the IO, as I told you that you have done. That is first. Second one is use nowadays all the microcontrollers are having the I2C controllers. Use them and write it. But this is only that. Now, for example, if it is RTC, you want to write the time, you want to set time. To set time, you will be setting that set date, set hour, set minutes. That you set it in your clock now. In your clock is, see, please understand, the clock and watch what you have is called RTC. Here they call chip. Okay, that's your clock is RTC. That's a real-time clock. In your clock, how do you set the time? If you buy any clock, let us assume a digital clock, you will press the buttons and set date and hour and minute. Then it will start doing that. Same thing here. When I start the new board, I will set the thing. But to set the date, I have to do this. Let us say I have 3 registers. Register 1 for date, register 2 for hours, and register 3 for minutes. I'll say I2C write 1. Sorry, address 0. 0, 1, 2, 3. Address 0. What is the date today? 16th. Okay, then I'll say I2C write. What is the date today? Hour. Now the hour is, let's say, 19. Then I2C write sorry. I've written I2C write 0 address 0 I've written 16. Then I2C write date address 1. Then I've written I2C write hours is 19. Then I2C write address 2. I2C write minutes is, now it's about 7:30. Am I right? Then I2C stop. So see that I am doing I2C start. I'm selecting the device RTC. Then at the address 0, I'm writing 16. Address 1, I'm writing 19. Address 2, I'm writing 30. Then I do I2C stop. But what I do here is I call this whole thing as set set I2C. Bracket, I have date, hour, minutes. There's a one function. But this function is good only for RTC, because if it is a temperature controller that have a different registers and different write, you cannot use the same thing. So please understand how we go from the bottom. The bottom, I have two wires. One is called STA, other one is SCK. That is done. And I control them using a controller. There, I write a function called I2C write to do that. Now, I use I2C write to write a function called set RTC. Set RTC. So that's why if you go and see the Arduino everywhere, they will have a functions like this. The problem is, with the moment you set RTC, it will work. But you will never understand how it works. In the interview, they will ask that. That's a trick. What I have told you that from STA, SCK, how this function. If you could clearly explain this path. But please understand one more thing. Whatever I'm telling, if by listening, you will forget. This is only a stage one. I make you to understand. Okay. But this is not final. If you would like to remember this, if you would like to answer the interview perfectly, understand. So if you try to remember this and try to answer perfectly in the interviews, then you have to practice. At least one timer we will do that. I will help you to understand about RTC or temperature controller. But all the other things, you should do it. Okay. Without you practicing, this is not possible. Whichever way you can practice, it doesn't matter. But before coming to this I2C, you need to complete the other one. That is your calculator project. Before completing the calculator project, don't come here. This is only I just I told you now. There are a lot of problems are there in this, the whole mechanism. That whether you agree or not, in my so many years of experience, I could have told that, no man, let us wait. Let us not discussing this I2C and SPI. You complete the calculator projects and come back to me. We will discuss about this I2C and RTC. You let us take a gap of 1 or 2 weeks. Then you will continue this 4 weeks after you complete. You know what happens? I tried that also previously, people. When you don't have the continuous touch with me on this, you totally forget. You have so many other tasks. And if I give even normally we say in the college, even if you give a study holidays, if I get 30 days or 60 days, I will study only the previous night. Okay. But this is your life. This is your life where you have to be very, very careful. That is the reason I know that at least let us make it live. Let us make the whole thing live. I know that this is not very, very useful to you. By knowing it is not going to be very useful, why I am discussing? There are 2 reasons. One is some of you who are completed, for them this will be useful. They will take off. But others, this will go into the years and keep it and make you to be the live touch with the programming. You will start doing it. You say that you will be thinking that you are still part of the program. Otherwise, if I say that, hey, let us get 2 weeks, let us take off. This 12, 13, 14, 15, we will do it after about 2 weeks, after people have done. You know one thing, after 2 weeks, we'll be in the same stage. Nothing would have been changed. Okay, so I'm into so much of dilemmas. I'm doing that. I have given another option. Don't worry. you listen to this, you proceed further. If you have a problem, we have a weekend batch. You can attend that and you can listen to that thing also. No, don't worry. I don't have even some of the first batch student have now joined the my third batch. I don't say no. I say fine. As long as you are happy, you learn. They said, sir, I joined the company. I'm fully busy. I'm starting fine. Somebody said I have exams throughout the last 2-3 months. I couldn't come back. My aim is to no. Now I'm telling you that this is not the perfect, efficient method. I know that, but I don't have any other method. If the other method means you have to be so perfect. If you are so perfect, the other method would work. So please try to understand and watch the video. I will tell you the thing. This is the bottom. You need to understand the bottom. The bottom one is this. SCL, SDA. That's the bottommost. And there you know that start, data, acknowledgement, this one. That is for 1 byte. Then you send another byte. Data 1, data 2, acknowledgement. Data 3, acknowledgement. Unfortunately, stop. Unfortunately, this data 1, data 2, data 3, there's no definition. That depends on the controller. If it is I2C, they will say something. For example, sometime when you are trying to read a memory, you can directly read about 100 bytes. You will keep on giving you 100 bytes, not only 1 byte. I give once a starting address. Data 1 will be starting address, maybe 100. Then I keep on reading. That will give you this at 100. This data will be 101, 100. Then this is address. I make read as a 1. Sorry, this is called the device address. Always data 1 will be device address. And read or write. I make read. Now I give an address 100. That's all. Next, I can read any number of bytes. He'll be giving me continuously the bytes. Okay. We have to do a lot of applications. I can show you anything, all my experience, but all will be waste. I've given you the very starting. Once you have done the bottom, you understand. Next one is we have discussed about how do I do the I2C controller. That has a byte. You write, he will do the thing. Okay. No, that is what I'm trying to say. That is not standard. That is what I have. The one example I showed you is 29. That may not be existing at all. You have to have the data sheet of the chip. I told you, next class we will take the data sheet and then we will do the thing. Yeah. Max is 7 bits. Please. There's a confusion once again now. Who said max is 7 bits? Now tell me that. I have a I2C device. Let us give a thing. I have a I2C device which has, let us assume that 64K. How much? 64K. The address starts from 0000 to FF. This guy address is now this is the I2C device. The device itself is having address. The device itself is having a device address. Okay, this is inside the I2C. Now I have I2C access. This device address is 0110001. Okay, the device address is 011110. 1 minute. Okay, the device address is 7-bit. So this 7-bit is used to select the device. Then I have a read or write. That's what we said. This constitutes the first byte. After you sending the start, the first byte tells you the device. Am I right? I may connect so many devices. Now, this device displays the acknowledgement to the master. Finish. Now I selected the device. Now only device is selected. This 7-bit is not for memory. Please understand, the memory is different, device is separate. The device, why 64K? I may be having 1 meg also. It doesn't matter. Now, let us take a small case. I have 64K now. Now, what will I do here? After sending this start, 7-bit device address and the read write. Now, I get acknowledgement. I'll write the acknowledgement different color. Then you will know that. I get acknowledgement. Then I give a 8-bit. This is 8-bit. This is not 7-bit. This is a 8-bit. Then the slave will give acknowledgement. Then once again, I'll send 8-bit. The slave will give acknowledgement. Then I'll give once again a 8-bit. And slave will give acknowledgement. I can send anything. Now, what is this 8-bit meaning? That depends on the device. In this case, our device is 64K RAM. So I make this as write as 0. That means that 1 means read, 0 means write. I make 0. Where do you want to write? Let us say, I want to write at address 4568. 45 is higher 8-bit, lower 8-bit. I send 45 here. I find 68 here. I write here 21. At 4568, I write 21 here. See that? How do I write? For example, my size is more than that. 16 meg, 00 to FF. I want to write 124568. I write data 73. Then I write first byte. Then second byte. Third byte. Fourth byte. First byte, I write 1, 2. Second byte, 4, 5, 6, 8. And I write data 73. Then for everything, I should get acknowledgement. For here also. So here you got it. Acknowledgement. Please understand, nobody knows. Nobody can tell you that what is this. They accept that what device you are using. There are thousands and thousands of I2C devices. You go and read all the I2C devices. That we will do that. We will do that. I'm not saying that I will not do that. I will take the I2C device and I'll try to do that. There's a conflict now. I thought I will take today I2C and spy. Let us see that if you want, we will take some data sheet now itself. Since we are discussing I2C, let me do that now, right now. Okay. Give me about a 5 minutes break. Then I'll take the data sheet and show it to you right now. Then you will not have a confusion. Yeah, device depends on how many devices you have. Device is nothing but how many devices you connect. How many ICs? One could be RAM. One could be temperature controller. One could be power supply monitor, power monitor. One could be your EEPROM. One could be RTC. You'll be using so many devices. This guy's address could be 25, 36, 71, 33, 15. Could be anybody. That means that 25 means 0, 1, 0, 0, 1, 0, 1. Sorry, I write it here. 0, 1, 0, 0, 1, 0, 1. And this guy, 36, 0, 1, 1, 0, 1, 1, 0, 36, 71, 1, 1, 1, 0, 0, 0, 1, 33, 0, 1, 1, 0, 0, 1, 1, 15, 0, 0, 1, 0, 1, 0, 1. Now, this is fixed. That is, after you send the start bit, this device address is always 7-bit. There are two standards. Forget about I see somebody will confuse. I know that. Suddenly you said 10-bit. We don't even understand I2C. Don't bring to the other standards. That means the device is not there. Then he will tell you that I'm unable to write. You are the software. You are looking for the bit. You know that after sending 8-bit, you look for acknowledgement. If you don't get acknowledgement, that the device is not there. That's it. Sometimes you see unable to write like that. Right. That is because of you don't get acknowledgement. For example, initially that guy will do auto detect. I will do that for I is equal to 0. Sorry, device address is equal to 0. Device address is equal to less than 128. Device address plus. I will check all the devices from 0 to 127. If somebody is sending acknowledgement, that guy is there. Somebody is not sending acknowledgement, that device is not there. Am I right? I send the device address. You know what I will do here? I will send only one thing. I will send start, device address, read or write, then look for acknowledgement, stop. If you don't get acknowledgement, I know that device is not there. Okay, so you will say that I find this is actually called scan. Every embedded system product, also there's a trick. It's another trick. All the product, most of the product will have a register called ID register. There's a called ID register. If you read the number, then you will know that what type of device it is. It is ROM or controller, everything you will do that. Okay, they're all next. Let us not go into the thing. So what I'm effectively saying is this. We are too much of confusing here. The trick was, that's why I always compare. When I give an address here in microprocessor, you put char star PTR. PTR is equal to 0x some 8000. That means the 8000 is 1000. If your memory is 32K, you will put this 15 address here. And you take one of the device, one address goes to the chip select. This is called, let us assume not 7. Let's take 7. Then it will be easy for us. This means that 512. Let us say I have 512K. That means I given a 9 address here. I given a 7 address here. This 7 address, this one is called device address. Here we call chip address. This is called memory address. Unfortunately, the 16-bit have everything together. In I2C, the same thing what we do here was, we give a device address as this 1000,000 separately. Then we have read and write this separately. Then we have a data 0000. If you understand this, the day you understand this and this are same, then you're done. There's no difference. But only method is I'm using the I2C to avoid too many pins. That's the only thing. Okay, let me pause it for a minute. Okay, do you see my data screen? Is it visible to you? Yes, thank you. Now let us see this. Now let us take a data sheet and discuss. This is a 8-pin chip. See here. Okay, you give a crystal here because it's a clock. This guy is supposed to count. That's why you put a crystal. He's having a clock generator inside. You are giving a crystal inside. Okay, then you are giving a this one power supply and the ground, and you connect the battery. Okay, when the power is gone, the chip will take the thing from battery. Then you have a SCL and STA, and we have a signal, some other signal called SQW or out. We will say what is that. See that this is the way you have to read it. What are the features? Okay, how much he consumes. See that when battery is working, he is consuming less than 500 nanoamperes. See that 500 nanoampere. That means that the battery will come lifelong. That is what the advantage of this guy. And another important is the temperature range. It is minus 40 degrees to plus 85 degrees. It's a wide range, all our temperatures. Now from the CPU, you connect SCL and STA, and both of them are pulled up to VCC. And here, this you have to see that description. What description he says? See that? It is also having a clock, plus he has a 56 bytes of SRAM. NV means non-volatile. That means that you can, because he is having a battery, whatever you write here, even though normally we said all the RAM will lose the data, since you are giving a power always, you can store something here. And this guy says that, you see here, AM, PM, 24 hours, that's all it is. You discuss all those things. I'm not coming. Now, he has so many parts. What's the temperature range and everything? Let us not worry about that. This supply voltage is typical 5 volt. You can go up to 4.5 and maximum is 5 volts. I mean, right. Logic 1 means from 2. He will accept that as a 1. Up to how much? VCC max is 5.5 plus 0.3. Okay. You see all the currents. The currents are all, when you do input output, they take very, very small currents that they mention. Then you see here, SCL clock frequency. See that? You cannot go beyond 100 kilohertz. That means that you have a pulse. Let me start the other one also. Let's see the thing. Your clock, SCK, you are pulsing. Am I right? You are sending a data. This time should not be more than how much? 100 kilohertz. That means 1 by 100 kilo. That means that milli. By 1000 by 1000, then you become micro. That means that 10 microsecond. So you cannot have less than that. That chip will not work. Okay. Then he has given all the things. What is the low period should be that? See that? High. If you put a high period, it should be 4 microsecond. Out of 10 microsecond, this has to be how much? 4 microseconds. And this has to be minimum 4.7. That's what he said. That it's all they given only minimum. That means that if you don't meet these things, then the I2C will not work. And we will discuss this later, maybe today itself. Setup and hold time. These two are very important. You should know that. Okay. And the rise time should be 100 nanosecond. That means that the rising time, this should be 1 microsecond maximum. That's what they given a maximum time. Then the minimum time, fall time should be 300. These are all called electrical characteristics of AC. That means that clock. What we have seen previously, this is called DC characteristics. That what is the voltage and everything. The timing is called AC electrical, and the other one is called DC. Okay, now we come here, and it's also say that how much the pin gives you the capacitance. That's a very important. Then you see here what is start, what is stop. Understood? They've given here. Then see here all the timings. Each and every timings are mentioned here. And if you could understand the block diagram, it's very nice. Okay, how that guy is doing. He has a memory of 56 by 8. He has a clock and calendar, and he is a user buffer for 7 bytes. Then the data goes here. This guy is the one who is converting serial to parallel and giving it to you. That's fine. If you go in depth, you can understand. This is nothing rocket science. This is all very simple. Now we see that SQW is called square wave output. Okay, so you can always mention the square wave. That gives you 4 kilohertz or 8 kilohertz or 32 kilohertz. You will get a square wave on the pin. So that's one extra feature. It is there on the chip. Now let us see the very important page. Okay. This is what they say that how you're supposed to do a PCB. If you don't follow these things, then I told you there's a crystal you are adding. The crystal should be how much? 32.768 kilohertz. That's all fixed. Now you see that. This is what for us, as a embedded system programmer, you should know that. See here, how many registers? 0, 1, up to 7. Okay. Beyond that, 0, 8 to 3F, it is called RAM. Okay. That is its range. You can write data from 0 to FF. That is called data. Then year, 0 to 99. See that? Seconds, minutes, hours, all the thing they're given it. You suppose right here that, for example, what I'm telling you is that this RTC chip, one thing we forgot. What is the address of the chip, which you have not seen anywhere? Where he has mentioned the address. I did not see this. Wait. Somewhere he has mentioned the address. Every chip I told you there's address. Let me search. 1 minute. Address, data. One minute. He'll mention that you should know the address. If you don't know the address, how do you able to talk to the chip? I told you, I cannot, I see so many data sheets. I don't remember. So whenever data sheet comes, I'll just go through that and find out. I cannot keep so many things in my brain because I don't remember the informations, but let me find out here. You see here, you see that here. I'll just make it bigger. You see here, they mentioned here. See here, the data sheet operate on two modes. Slave receiver mode. In that mode, you see this address 110.10.0.0. This is what is address. Okay. Other one is read mode. You can write or read. Okay. That is why they are saying the two modes. You see here, start, device address, and this is called write. I told you one means read, this means write. Then acknowledgement. Then we have a word address and data. See, up to data n. You can keep on writing the data. Okay, that you have to understand how they are working. Now you see the thing, acknowledgement, then do this one. Stop. Okay. So to just put you difference between S and P, they put P here for stop. See, the thing is that this is the Bible. This is a chip manufactured by the Maxim, the company. Then how can you say that you will assume anything? Don't assume. Read the data sheet and do what that guy says. That how early you try to understand. That early is important information for you. Don't. They're all very small. See, this chip is having how many pages? Only 14 pages. There are only 14 pages. If you just understand the 14 pages, you're done. Same. See that what exactly we discussed. Start this address 110.0.0.1 and 0. This address for the chip is fixed by the company Maxim. You cannot do anything. No other company should have the same address. Then how do you do that? If I have, let us say that I buy two chips. Let us say I buy a chip from a Maxim. Let us assume that. See, now I have a big problem. I buy this chip. What is this? DS 1307 by I2C by Maxim. Now I have some other chip. Okay, some motor controllers. That guy also having 110.100. This guy also having 110.1.0.0.0. If you connect the I2C, SDA and SCL. Now, if you give the address, who will respond? Who will respond now? In the interview, somebody asks you this, what will be your answer? From the discussion, what we have done so far, in an interview, somebody asks this, what will be your answer? What will be your answer? This is exactly the same question I asked you. If you remember the digital days, I asked you the question. If you just recollect the digital case, there'll be a question people will ask you. See here, this is the AND gate. This is the OR gate. I have an input, connected output. Both are 0, 1. What will be the output? What will be the output? This is illegal. Am I right? That is what this is illegal. You are not, the moment somebody writes, if they ask you that, if you select both the devices, you should immediately say that this connection is illegal. The moment you say this connection is illegal, you win 50% of the interview. He knows that, oh God, no two devices should have the same address. So on I2C bus, no two devices should have the same address. Then he will ask, what will I do? How do I connect? Then you should say that I will use a I have two devices of same address. STA, SCK. STA 1, 0, SCK 0. STA 1, SCK 1. What is this device? Anybody? What is this device? This is called I2C mux. There is one more pin is available here. There is one more pin is available here, which I should get out of my microcontroller. From microcontroller. That if it is 0 means this will be connected. I can check. When this guy is 1 means this will be connected. Understood? I cannot connect both the devices simultaneously. Okay, let me try to find the data sheet for I2C mux also. It's very good, man. I'm like you. See, try to do what I'm not doing anything secret, man. See that I'm doing exactly what you do, I do in the companies. There's no other method. See here, I2C mux. See, this is the chip from Texas Instruments. 4-channel. How it is differentiate between the address 0 . No, addresses are given by the data sheet. I showed you here. When you go into this guy, this address is given by the data sheet. That means that chip address is given by the company.
Yes, sir.
Yeah.
Sir, I'm saying like the address is 110100, and then there is a 0.
Well, that 0 is for write or read. If you make it 1, it's called read. If it is 0, means write. I told you now that one is device address 7-bit, 1 bit is called read and write. That is read or write. Okay, that is not free defect. Yes. This you can change, but this you cannot change. Okay, then that is correct. Now let us go here. I open the data sheet here. That's why I'm trying to show you the exact how we do that in the company. Exactly what I do the company I'm showing you. There's nothing. I'm not hiding any secret or anything. You need to understand that. I could keep everything readily available and show it. I don't do that. I exactly do it before you. One minute. I'm very comfortable in using the. But it will take slightly more time, but you understand the reality. This is what exactly everybody in the industry does it. Whoever it is, however experienced they are doing the same thing. You see here, this is four-channel. I'll discuss about later what is SM bus. It's I2C and SM bus are same. Now you see here. You see here. This is a block diagram. See here, that guy is had 1, 2, 3, 4 channels. This guy is, there's a chip called PCA 9544A from Texas Instruments. From the master, from the microcontroller, you connect to this guy. And these are all the devices. Forget about interrupt. That's I'm not worried about interrupt. This is I2C only. Now this A0, A1, they use it for this one, a master I2C. That I'll tell you now. What is the meaning of the A0, A1, A2? That I have not explained to you now. Okay, so there are this guy. Now I'll go back to the board. Now I showed you two things. Now I've showed you two things that how do what is called mux. This is 1 to 4 mux. That means that I connect each one. I can connect 127 device. 127 into 4 can be connected on a single system if I use this mux. This is separate bus. This is separate bus. Channel 0, channel 1, channel 2, channel 3. Like this. As I go back to the board, I'm very comfortable. Stop the sharing. Okay, now I'll go to the board. Okay. The trick here is I have a master and I have I2C bus and I have a switches. And here, this is a channel bus 0. Bus 1. I can have a device here 14. I can have device 14. I can have 14. I can have 14, no problem. Because I will on one switch and control it. That is why I do that. But sometimes if every manufacturer says that they fix the address 14, 15 like that, you buy a 2 chip, both are having 15, you have to buy a mux. So what the manufacturer did, one interesting thing, a lot of manufacturer, they fix, if you buy a chip, they fix the first 4 bit. My first 4 bit is 1100. This guy first 4 bit is let's say 110. Both are same chip. Let us say RTC. Let's say you want a 2 RTC, for example. But they don't give you how many bits. Let us say it's of RTC I got EEPROM. Now they don't give you how many bits, 7 bits. They give you how many bits? Only 4 bits. The remaining 3 bits. This is address 7, address 6, address 5, address 4. The remaining 3 bits, address 0, address 1, address 2 are given to you on the pin. If you connect all of them to ground, this guy address is 000. If you make J0 is high and the other 10 grounded, this guy address is 001. That means that I can connect both the devices on the same bus. What they are telling you is that they are given, apart from the SCK and STA, plus voltage, 5 volt and ground. They have given 3 more extra pins. That 3 more extra pins will help you to select the device lower 3 bits. That means that I can connect one more EEPROM. I can make the address 110010. That means that I will connect these 2 pin ground, A0 and A2. A1 I connected to 5 volt. This is on the chip. That is the reason I showed you on the chip. That the chip itself, the manufacturer, that manufacturer has shown that here, the addresses A0, A1 and A2. If you see in the top, they would have mentioned to you that we'll see the data sheet. We'll see the data's address pins. Oh, this guy is having A0, A1, A2. Now let us see here. They see that A0, A1, A2. See that they are address input 0, 1, 2. And you should see the remaining 4 bits. Am I right? Let's see that where they given the remaining 4 bits. You should have a 7 bits. Am I right? I think in the bottom they are trying to access, given the detail they would have given mentioned. See, everybody is same, man. You see that? Stop, start condition, address, same. If you see the data sheets, you will thoroughly understand that what they are trying to say. I wanted to see that 4 bits. This is all I've used some long time back. The trick here is very confused. These are all generally normally second stage it comes. But today interviews, they ask all these things. Here, you see here, this guy address is one IO. I have written same thing, man. I don't know if it's a perfect coincidence. 1110. That guy also given address is 1110. The remaining 3 addresses are A2, A1, A0. Am I right? This is what fixed by the, this 1110 is fixed by the company. You cannot do anything. Am I right? So, this you have to read. What is about 36 page. If you could understand the 36 page, you are good. If you say that, if you tell, see, you will think that this is something small. But the moment you say that I worked on I2C Mux, you say that I know 9544. I can pick up few MNC companies where you will be selected. If you know the I2C, if you read that 3 components, I2C bus and the things. Okay, so if you tell the companies that you worked on the I2C Mux, and if you know that how this I2C Mux works, they will ask you that where you encounter. Okay, I'll give you all this where you encounter this problem, where you have to use the mouse, all those things. You are the winner. Okay. So, generally don't think that I2C is small. I2C is small. You'll be very surprised. At the age of 53, I was asked by the Gigamon. The interview from US people have called. You know what they asked? Do you know about I2C Max? You know I2C. I said, yeah, they're fine. Then he asked, when you do that? That's it. I could, now I'm telling you everything I was telling him. Selected, man. So easy. This, you don't know. I'm telling you now. You think these are all small. For you, right now, PIC or ARM or 8051 is in mind. But for the companies, these are all big because they are not good. They have all the processes already built in. But what they want you to write a software for connecting the devices, they are more. That's why I explained all those things. Now I'm explaining in depth of these things. Even though today I had an original plan was I will do the this one. What do you call it? I'll finish today I2C and SPY. Finish. I said no. I from the people doubt, I've understood. I immediately gone back. Okay. I thought next week I can show this data sheet. But today I thought, okay, we are discussing I2C. If you show the same data sheet, then you have done. The only thing is next week we have to show some this one protocols. You will understand. At the time I will try to capture the waveforms. I will show you the live. We will take 2 controllers. I will take the one, whichever it is, 8051 Arduino or ARM. Then we will do the what do you call it? Trying to hide the RTC chip. Then we will see that I will show you all the diagrams. Then you will know that how the whole thing, what I discuss. If you see a software, then you will do it very perfectly. Okay. You can ask me any doubts now. You can ask me any doubts. I've shown data sheets. I've shown two data sheets. One is I2C chip. Other one is MUX. Don't worry. I will make all the scenarios and I can bombard the information. But the problem is there are two. I told you now. There are two ways you can get into the company. One is full expertise and go. That'll take very long time. You cannot do that. But the problem is do the one or two projects and extrapolate. That is the trick you should have. The moment you know the basics, you do one or two projects and you can extrapolate as if you have done about 10 projects. But somehow you should make sure that in the interview they ask you the questions only in one or two, not the other ones. That's a trick. If you have to do all the 10 projects and then only go for interview, it'll take very long time. But these are all very important. As I told you that I2C, MUX, the same way when you go to the SPY, I'll tell you some more extra information. Okay, there's something called C pole. Okay, C phase. You should know that. Same way, setup, hold. Today I thought I'll discuss setup and hold also. No, I don't want to have a setup and hold time as a recorded one. I know that floating point I was happy recording, but not the setup and hold time. I want lively you ask doubts. Now you ask the doubt on the this one. Then only I can able to explain. I myself is having a problem. Yeah, MUX is having a register. Oh, that's a very good question. Somebody asked MUX, how do you select? Now you see here, MUX. I told you the MUX is having 1110, and there are 3 bits. A0, A1, and A2. You connect all of them ground. So this guy address is 000. Am I right? This is a MUX. PCA, what is that? 5944, I think, and 9544 or something. One of them. Okay. Forget about that. That's not a very still it's not doesn't let me see that. Let me have a look. 9544. That's correct. I remember correctly. So no problem. So these are all sometime I cannot just like that do that. That's the thing. Now I have a microcontroller which is connected to this guy through SDA and SCL. And here am I right? This data. Now this guy is having a register internally. So when I do this guy address 1110001 to this guy, okay, then this guy will be selected. You can write into the address. You can select what channel you want. You can select what channel you want. Then this will be connected. Afterwards, all the access what you do, it will be done there. Okay, that this data sheet is only some 36 pages. All the other data sheets, if you see that there will be about hundreds and thousands of pages. This guy is only 36 pages. You can read and understand. This guy is having that. This microcontroller, this is an I2C device. I write into the register and select the device. Then once it is selected, then that guy will go there. Okay. That's the way I select the MUX. And each and every guy is having a different mechanism. Okay. That's the easiest mechanism they follow. So this guy is having a register to select the mux, for which channel you want. Any other doubts?
Sir, can I say?
Hello, tell me.
Sir, my understanding is like at the end we have to make one or two projects. Likewise, we use in our daily life like a TV remote, so that and we don't know because at the end where we will land on which product we will working. So this is what I'm getting, right, sir?
Very good. That's very good. You should do that. That's correct. Perfectly. If you could do the TV remote, then very nice. Okay, start doing that. That's very nice. You use the IR receiver and do. I'll explain that also how the IR receiver works. Then you can able to do the product. That's nice. You can control your house fan or bulb, everything using your microcontroller based product. That'll be nice. If you want to, I'll do one thing. I will list like a calculator. I can list about calculator is a nice project. You can put the buttons, you can make the LCD display, you can give it to people and use it. This is my calculator. This is a very nice project. You remove the Arduino, everything. You take only the chip out and you connect the wires and enough. It will be a small product. Use the Arduino board, put the chip and do all the programming, everything. Finally, take the chip alone out and put it on your board and solder it and start giving the product. You will know that how people enjoy it. Understand? It's my calculator, man. You have done a calculator. You think that calculator is something big, but your calculator is very good. We can do a lot of projects. I told you now, I'll be here with you. If you start doing a project, I can help you. But before that, understand the whole. See, the problem is companies looks at your project for one information. How motivated you are. How determined you are. How you do from start to end. Can you able to withstand start to end? Can you document the whole project very clearly? Can you explain the project very clearly? Can you able to this one all your bugs? How do you handle the bugs? If you say the thing, hey, the calculator on the keypad, how did you overcome this problem, man? When you do that, they will ask you. If you've really done the project, you will explain. That's the thing. But this is only one level. But if you don't have the proper knowledge, this will not help. You should have both. What we are discussing, the things are all the proper knowledge and with the project. That's it, that you can do the project in two ways. Without knowledge, by skill. Take a lot of things from the net. Don't understand why I connect the wire. Don't understand why I do that. If the people ask one or two information, you don't know that. But if you do with the proper knowledge, that is the only difference with what I try to make. I want that if you do a project, I want you to be very good in everything. You should know that every wire, what you connect, you should know that. Just take some time. But you will reap the benefits. You will reap the benefits. I could have started the ESP on the day one. Hey, this is what the microcontroller, this is what the PO, this is what the PA, and you output the PA, it will go. Why I have not done? Why I took about 2-3 weeks? Because you are not going for a small companies. You are trying to understand, go for a bigger companies. They will ask you all these knowledge-based questions. Yeah, 44th sum. Let me stop the thing and then recording, I'll do the thing.